Right, so we're still talking equivalent fractions. Okay, so end of last lesson we were on this question here, right? Looking at finding equivalent fractions on the diagrams. So let's just finish this question off if we can. So we've got these two diagrams. Let me make them bigger for you. Right, we've got to show that 2/3, 4/6 and 2/18 are equivalent. Now, I'm kind of hoping from you guys that without the diagrams you could tell me why they're equivalent anyway, and then we'll look at the diagram. So how can I say, how do I know that 2/3, 4/6 and 12/18 are equivalent? Tamar.
It doesn't really make sense. It's like, it says if you have 2/3 and then 4/6, it's like times 2, but then 12 and 18. So like, how does
Okay, well maybe Thomas will explain.
Isn't it 2 times 2?
So 2/3.
It's 3.
2 times 2, 4. 3 times 2, 6.
Okay, so we've shown that 2/3 and 4/6 are equivalent. So
it's times 3 then. It's times 3.
okay, so 2/3 to 12/18 is times
By 2. No.
3. Like
6.
6.
Yeah.
Times 6. Okay.
And then if you do,
If we did 4/6
it's
to
3.
12/18
It's times 3.
is now
Times
times 3.
Oh.
So we have shown that all of those fractions are equivalent, but what I want to make sure you understand is this timesing thing, right, that we've been doing. So the timesing by 2, timesing by 6, timesing by 3, what do we actually do with the diagram? Right? Well, I want you to understand, because that, when we get the cakes out, I need you to understand what do we do. So the timesing by 2 is actually the same as something else. So for instance, if I wanted to show 2/3 of this diagram, Thomas, what would I do?
So you would split the diagram into 3 sections.
Okay, and how would you like to do that?
Over here.
He's coming.
One over here. 2 there.
Okay, yeah, so one there.
And then one another there.
So you're going to split it here. Oh,
Oh.
wrong pen. Oh. So, okay, so you want to split it there. I'm going to do that all the way through.
It's easy.
Okay. So I've got there and. Come on.
And
It's it when it does that.
Well, what you could do is for the second one, 4 out of 6. On the
Okay,
middle
so
one, you'll have to do
right, hang
more
on.
lines.
Before we go there, let's not get to. How do I show 2/3?
you shade it in
So shade in
2 sections.
2. So that's one section.
And that's the other
That's
one.
the second section. So the fact they're equivalent means that every diagram has to have the same amount shaded.
But
So what we need to do is, let's imagine that they are cakes, alright? So we've got to think, well, how do I show that 2/3 is 4/6? What do I have to do on this diagram to show it's 4/6?
You split it into 6 1.
And how are you going to do that?
You put like more lines in.
I put more lines in, brilliant, yeah.
you cut across here.
Yeah, there.
Along there.
Okay, well I'm going to
Jesus.
just cut that one
Yeah.
like that, yeah?
Yeah.
Or you can
Yeah.
take that red line away and just cut through the middle.
Yeah.
I could just
Yeah,
cut
but
straight
then-
down the middle, but there's no lines then.
Yeah, but then it's a bad line. So it's
Yeah.
not nice to do that.
So
Like
by
that.
splitting it here, so here I've got 1, 2, 3 sections, so that's
But then
2 out of 3.
2/3.
Here I've got 1, 2, 3, 4,
5,
6 sections, so I've got 4 out of 6. Then, alright, How, though, is that the times by 2? What did I actually do to the diagram?
You halved it.
Okay, so timesing by 2 actually divides everything by 2 in reality. So by timesing the numerator, you actually half the size of each piece, but you've got double the number of those pieces. So do you understand that? So this number is basically, by making that from a 3 to a 6, each piece is actually half as big.
Yeah.
But by timesing by 2, it means we've got twice as many pieces.
Yeah.
So this is the size of the piece, and this is how many. So you can half the size as long as you have twice as many pieces, and then you keep the same. All right. So this one, so let's have a look. So we could do the times, break it into 6, or we could do this one divided into 3. So which one do we want to do? The from here to 6, I guess, is easier. Then. So we take one of these sections and we split it into it.
Yeah, like that.
Yeah,
so
like
then you have 6.
So we divide the size by 6, but we have
more pieces.
6 times as many pieces. Yeah. Okay, so 1, 2, 3, 4, 5, 6. So instead of 1 piece, I've now got 6 pieces, and out of 2 instead of 2, I've got 12.
12.
And then 18 in total.
Yeah.
And 18 in total. So that's how we've shown. Okay.
Okay.
Right. The next thing I've got for you to do.
Wow.
This diagram. This is a diagram to help you look at the equivalence of fractions. Okay? So
Cool. It looks like a mouse.
I've got one of these for you to look at. Okay?
What's the little one on top?
Don't stick it in
there's
straight
a no one.
Okay, so basically, this is what we're looking at. So on your sheet, you will notice that the very top bar is one whole bar. Now, it doesn't actually matter how big that whole bar is. A fraction of the whole depends on what you start with. So a half of whatever you started with, well, it's a half. Yeah? So this is the whole 1. The 1 out of 1 is, you can only have 1 out of 1 or 0 out of 1, that's it. Okay. But what they want you to do with this diagram, when you're going to get your rulers out, is you take the 1 and you split it in half. And therefore you have 1/2 and 1/2. Alright?
Oh!
Now,
And then you do it with the 3/3.
yeah, so, but here's the thing that we can do, is that if that line, right, if I draw that line all the way down,
Oh, you're going to have to do a lot.
okay, right, that line matches up with
Lots of others.
2/4, 3/6, 4/8,
Oh, it's always a half.
5/10.
Yes.
Oh, yeah.
They are all
Half.
halves.
Oh, I
And
get
then
it.
on the right, they're all wholes.
Yeah, so 2
2
out of 2, 3 out of 3, 4 out of 4, 5 out, they're all wholes. So what you're going to do, so you can use your ruler, you've got some questions just down here, find a fraction, replace it, and you know that 3/5 is the same as 6/10 because you line a ruler, right? So you take your ruler, you find 3/5 and you mark down, and you see that it also goes through 6/10. So therefore 3/5 and 6/10 are equivalent fractions.
Cool.
Alright? So then what it's asking you to do is use the fraction chart and a ruler to write down equivalents to a half. Well, we've done a half, but 2/3, 2/6, 1/5. So, but that's got to be, you've got to write them in your book, please.
So we write down the equivalent fractions.
Write down all the equivalents that are on that diagram. Okay.
Wait, so like from top to bottom.
Yeah, so we've done a half for you, it's all of those. So you'd have to write a half equals 2 over 4 equals 4 over 3 over 6, 4 out of it, and so on.
Let
Okay?
me do that for you.
And you do it for, write them all down and then do it for 2, 3, 4. In your book, I want you to write those answers down, please, in a nice, structured, neat, ordered way. So you're going to put a title of equivalent fractions. Okay? You can use the sheets with your ruler, but you're going to write half equals 2 quarters equals 3 over 6 equals 4 over 8 equals 5 over 10 equals 6 over 12. That's the first one done for you. You're going to do the same. Alright, and then we'll put the graph in afterwards.
So we just go from top to bottom.
Top to bottom. Find the one it says, and then work out all the ones that are equivalent by using the line.
Okay.
Afterwards, we'll talk about what the effect of the size has on it. Okay? Got that?
Yeah.
Right. Do that. Shouldn't take you too long. Okay, gents, I would like to talk about another thing. A question you actually asked, Rachel. So if we stop at the moment, you can go back and do it. It's actually an important thing. Now, you asked the question. You asked, can you have a half over 2? Okay? Now, if we think of over, a fraction, as a division, what we're actually asking is, can we do a half divided by 2? So we can't write this, right? We don't write it, but what we can do is evaluate it. Pay attention, Thomas. You're going to need to. All right? So what we're saying, we're going to be looking at this with the cakes. All right? So for instance, if we have half a cake, and I need to share half a cake with 2 people.
Oh,
Quarters. Right? Right? So that's what we can look at with this diagram as well. So for instance, if I have 1 half, and I want to know what half of a half is,
it is
go half, go down, we have a quarter. What is half a quarter?
Half a quarter is 1/6.
No, not quite.
Oh, 1/7. 1/8. Oh my gosh, it's 1/8. Oh, I failed.
Right, okay.
1/8.
So,
And half of
1 quarter divided by 2 is 1/8. What do you think 1/8 divided by 2 is? It's not on your diagram.
It's it's
1/16.
Yeah.
Right, do you remember I said this denominator is how big the size is? Alright? So the bigger the number,
The bigger the denominator.
the bigger the denominator, the
smaller the smaller
smaller the
that
piece.
piece.
Oh, yeah.
And you've got to think of it in that way. So, if I have a fraction, right, for instance, let's say I've got 2/6. Alright? If I want 2 lots of 2/6, alright, what do I have?
2 12.
So 2 times, sorry, I'm 2/6 times 2 is,
4
about it, because 2/6,
Oh, 4 6.
another 2/6 is
4 6.
4/6.
Oh.
Because
Oh,
you
yeah,
when the
one.
time
Because look, let's just check this. I want you to be very careful. 4/12 is here. And 4/12 is actually the same as 2/6. So I can't have 2/6 twice and only have 4/12. Think of it as cake sizes. So if I don't change the size of the piece of cake, but I double the amount I've got, I must just double the number of pieces. So 4 out of the 6, yeah? But if I have 2/6 divide by 2, the answer would be 2/6 divided by 2 is 1/6, okay? Or I'm going to write 2/12 to start with. which is 1/6. Right? Make sense or not? Okay, so 2/6, cut it in half, 1/6, which is also 2/12. Okay. Now the reason why I did 2/12 instead of 1/6 straight away is because what I want, hopefully you would notice, is that if I'm timesing by 2, I do the top number to become 4. If I divide by 2, it's the bottom number.
So say it's like 3/12 times by
3/12 times 4 is
12 times
12/12.
12.
If I have 3/12 divide by 4, I have
3/3.
3 over
3.
Oh,
no.
4. What? 12 divided by 4.
No, do you remember I said if it's divide by 2, this number gets
Higher.
so 6 times 2, so we get smaller pieces, don't we?
This is
So
confusing.
we get
24.
3 out of
48.
48
Oh,
pieces.
I get it. I completely get it now.
Oh my god.
Oh wait. What if?
Oh, so
If we have
so you times the
1/5 times 3.
that's 3 over 5.
If I have 1/5 divide by 3, I have
That'd be
15.
1/15.
1 over 15.
Because you cannot have a smaller number over the top number.
Well, you can, but what I'm saying is think again, and we're gonna do this. Think, if I times by 3, I'm saying you can have 3 pieces that are that size. Take 3. Instead of 1, you can have 3. Yeah? But if I say I'm dividing by 3,
I control it.
if I say I'm dividing by 3, is it all gone?
Where'd it go?
Let's go.
Oh, there.
Oh, you.
I controlled it.
If I say I'm dividing by 3, I'm not giving you more pieces. I'm actually splitting your piece into 3, and you only get 1 of those. So if I've got 1/5 of a piece of cake, but all the pieces get split into 3, how many pieces are there now? So there are 5 pieces, but I've got to cut them all into 3.
1 out of 15.
I end up with 15 pieces,
Yeah.
and I still only get 1 of them, and that divides what you have by 3. Yeah?
Oh,
Makes sense?
yeah.
So what we'll do is, I've got the pie, we'll have a look at what happens when we do that. So you should visualise now, if I say to you, here is a quarter of a cake, I'm going to give each one of you a fair slice of only that quarter. How much would you get as a fraction?
Out of all of us.
No, like 1 over 4 for each.
It's
1/16.
Yeah. 1/16.
Oh. Oh my god.
Oh my god.
Yeah.
But how are we going to do that mathematically wise? Like exactly.
Well, we'll see better when we've got them. It'll make sense. And then, for instance, another question, there are only 2 donuts. All right, there are 2 donuts.
Half each.
We're going to 5 people.
All 5 of us.
I know how to do that. I did that on the
Right, here's the
diagnostic
question.
test. I did that on the diagnostic.
If there are 2 donuts and 5 people, what fraction of a donut
Yeah, but it's going to be.
do I get? You've got to be able to work that out, otherwise you don't get the donut.
No. Are you serious?
Yes.
What
I
about the
answered.
pie?
The same as the pie. If you don't get the right answer, you do not get the pie. That's the deal. It's not just a freebie cake thing. It's you tell me the right answer, you get it. So maybe think that through.
Yeah.
So I'm going to be saying, for instance, maybe I'll go, oh, the cake has been split into thirds. Right? 1 for period 1, 1 for period 2, 1 for period 3. Now you have to share each one of those thirds between all 5 of us. What fraction are you going to get of the entire cake? Got 2 donuts.
We need
between
5.
5 of this, what fraction of the 2 donuts do you get?
Well, where would you?
Is what I want to
Where
know.
would
That's
you?
what we're going to talk
I
about. So,
didn't
hang on. No, don't tell me now. But that's what you've got to think. So after break,
Can we do it at a break, like on a piece of paper?
you can try. But you don't know what question I'm going to ask.
We'll write down all the possible ones.
Okay, well, that's up to you.
Oh,
Right,
500.
the next I would like now.
Scared.
So this sheet, activity 10.2, is about by just writing down the equivalent fraction. So with this, okay,
Is it now?
right, you're just going to find the missing number for the equivalent fraction
Okay.
by multiplying or dividing.
Can we work together?
Yeah.
Okay.
Okay.
Yeah, sure. Oh, but that's so